Okay, this is the test review for Chapter 6. I'm going to work about half of the problems from every section, so I'm not going to work every problem. In the first section, let's look at number 1. We have y equals 1/3 x plus 4. We're looking for the inverse, so I'm going to take the x value and the y, and I'm going to switch them. And now I want to get y by itself, so I'm going to subtract 4 from both sides. X minus 4 equals 1/3 y. And then to get y by itself, I'm going to multiply by the reciprocal of 1/3, which is 3, which means I'm going to multiply by 3 on the left side also. So I get 3x minus 4 equals y, because 1/3 and 3 cancel. And that's the inverse, just like that. For the second problem, the first thing you might need to do is change f of x into y. And you may see this part that says x is greater than or equal to 0. That's just extra information. It's not going to affect my inverse, so I'm going to leave that the way it is. So I'm going to take the y and the x and I'm going to switch them. Actually, I should have said the x is greater than or equal to 0 is not going to affect the inverse process. So if I take the x and y and switch them, and now I want to get y by itself, so I'm going to subtract 9 from both sides. Then I'm going to divide by 4 on both sides. So I have x minus 9 over 4 equals y squared. To get rid of the square, I'm going to square root both sides. So I have the square root of x minus 9 over 4 equals y. Now some of you have asked me about whether or not this needs a plus or minus symbol in front, and it does not. That's what this little x is greater than or equal to 0 thing tells me. It just tells me that my answer is going to be positive. We don't need a plus minus sign here in the front of this problem. We can just leave it as the square root of x minus 9 over 4. Alright, let's look at one more of these. If I take the x and the y and I switch them, I have this situation. This one has a square root in it, so let's see what we're going to do. Add 5 first. So x plus 5 equals the square root of y. Now I want y to be by itself, and it's under a square root, so the opposite thing to do is to square both sides. And I'm going to leave this as x plus 5 parentheses squared equals y. Although we could multiply this left side out over here, we're not going to unless we absolutely have to. So there's my answer. So those were the inverse problems. Well, finding the inverse problems. The next section, you're verifying, and so I'm going to do some verifying here with, first of all, f of g of x. And I'm going to use the different colors I've got. So f of g of x is going to use the f function, which is going to look like this. If I take the x out of the f function, it looks like 2 times something minus 4. Okay? So I'm going to take the g function in red, which is 1/2 x plus 2, and I'm going to fill it in that spot. And then now I'm going to begin to simplify. So let's distribute my 2. Well, 2 times 1/2, right here, 2 times 1/2, that cancels. So that just leaves me with x plus 2 times 2, which is 4. And then we have the minus 4 that we're going to bring down right here. Okay, so I have x plus 4 minus 4, which cancels and leaves me with x, which is what my goal is to begin with. Alright, now, how about if we do g of f of x? This time we're going to start with the g function, so I'm going to start with the red. I'm going to leave a big gap where the x is in the problem. I'm going to replace that gap with 2x minus 4, which is from the f function, which is in black, so you can see now what's being substituted from where. Now if I simplify this, 1/2 times 2x is just x. 1/2 times 4, it's really a negative 4, so 1/2 times negative 4 is 2. Then I have plus 2 at the end. And of course, looking at this, minus 2 plus 2 cancels and we're left with x. This is your goal, and when it tells you to verify, you know that it's going to equal x, you just have to show the steps. Alright, so for number 8, since there's only 3 problems in this section, I'm going to work the first half of the section, and then you can do the second part of your own. So I'm going to find f of g of x. So I'm going to take the f function, I'm going to leave a big gap where the x is supposed to be, and I'm going to put the g function inside of there. And now I'm going to work this. So this is a square root that is squared, and so squaring a square root cancels. What does that leave me with? 5 times x over 5. The 5's are going to cancel, and what does that leave me with? X, which is what's supposed to be. Now you're going to do the g of f of x part on your own, and you can check with me. Alright, number 10 is the next problem I'm going to work, and I'm going to be graphing this problem. And I think the question asks about its inverse. So let's just start with graphing. Remember that x squared means it's going to have this shape, which is a parabola, and x squared minus 2 means it's been shifted down 2 places. So starting at the origin, I'm going to go down 2 places to put my vertex. I have a slope of 1, so I'm going to go up 1 on each side. I'm going to connect these dots, and there's my problem. Now, what this question is asking is about its inverse. Is the inverse of this a function? Well, how do we know? Well, we're going to do what's called the horizontal line test. Okay? Horizontal line. Horizontal line. With the horizontal line test, if the red line touches my green graph in more than one place, then this is not a function. If it only touched once, it would be a function, but since it touches twice, this is not a function. So what you're looking for is to graph whatever the f of x is, do the horizontal line, and if it touches more than one time, it's not a function. And if it only touches one time, then you just write yes, it is. Alright, number 12 is asking you about how can you determine inverses from tables. Well, remember that to find an inverse, you take the x and the y and you switch them. So let's say I had a table that was 1, 2, 3, 6, 5, negative 2. What would its inverse table look like? The inverse table would look like the x's and the y's were switched. So this would be 2, 1, 6, 3, and negative 2, 5. So how can you tell an inverse from the table? Well, the x values and the y values would be switched. Alright, number 13, we're going to graph this, determine its domain and its range in some of the transformations. So we have 3 plus the square root of x. If you feel better, you could rewrite this as the square root of x plus 3. We know the plus 3 is going to shift this up 3 units, so I'm going to start at 3. There's a slope of 1, so I'm going to go up 1 and right 1. And now we know it's a square root, so it's going to have this shape, this half sideways parabola shape. So there's my picture. The domain you can figure out from looking at that center point, that starting point. This starting point is at 0, 3. So the x value is 0, the y value is 3. So when I do the x and the y for the range and the domain, well, x is going to be 0 and y is going to be 3. Since this goes to the right, it's greater than or equal to. Since this goes up and to the right, this is greater than or equal to. So there's my domain and my range. What was the transformation? Well, we only had one, and it was a transformation that shifted this graph up 3 units. For number 14, to graph this I'm going to have shifting it up 2. I also have a slope of negative 4. Okay, so I'm going to start off by shifting it up 2 places as my starting point. My slope is negative 4, so I'm going to go down 4 places. 1, 2, 3, 4, and over 1. And so my picture, if I can draw very well, it's going to be stretched out, but it's still going to be half of a sideways parabola. So there's the general picture. So the domain and the range, well, what's the starting point? 0, 2. This is the x and this is the y, so x, y, the x is going to be 0, the y is going to be 2. Now, this goes to the right as it goes downward. So the right tells me greater than or equal to, and the downward part tells me less than or equal to. Now what are the transformations? Well, the plus 2 gave us up 2. Well, what did the negative do? It switched the direction. Instead of going upwards, this goes downwards, so it's been reflected. And then what's the final thing that's happening here? The slope is 4, which causes it to be a stretch of 4. Okay, number 17, 18, and 19. I think I've got number 20 on here, but 17, 18, and 19, you have words that you're going to write into an equation. So reflected means I'm going to have a negative slope across the x-axis, which that's typically how it is. It's shifted right 5 places. So remember, anything right or left goes inside parentheses. Right is going to be negative because anything in the parentheses is opposite of what you expect it to be. So right 5 is going to be negative 5. Up 7 is going to be outside of the parentheses. Up is plus, and so it's going to be plus 7. So we're going to have negative the square root of x minus 5. And on the outside of the square root we have plus 7. So there is the equation that matches these words. Alright, number 20 gives you a picture instead of giving you the words. So we had to figure out for ourselves. How far to the right is it shifted? 4 places. How far down has this been shifted? 5 places. From the first dot to the second dot, it just goes negative 1. So that's basically like my slope. So if I write this equation, I'm going to say y is negative 1 square root x minus 4, because right means minus, down 5 means minus 5, so we're going to have minus 5 at the end. So negative square root x minus 4 minus 5. Okay, if I have this equation, y equals 3 times the square root of x, and I'm going to shift it 2 places to the left. Left means plus 2. This is inside of parentheses. Now keep in mind the parentheses of a square root function are going to be the absolute value, not absolute value, the square root symbol. That's where my parentheses are. So x plus 2, that's going to be shifting it 2 units to the left. And then this already had a 3. So all we've done is rewrite this graph to where it also has a shift of 2 places to the left. Okay. Let's do some solving. If I have the square root of 6x plus 15 equals 9, the first thing I'm going to do is get rid of my square root. You square a square root, and it cancels. So I have 6x plus 15 equals 81. Now I just need to solve this for x. Minus 15 on both sides. So 6x is going to equal 66. Divide by 6 on both sides, so x is going to be equal to 11. Number 24, my square root symbol is not isolated yet, so we're going to start off by subtracting 7 from both sides, which leaves me with a negative square root of x minus 4 equals negative 13. I'm going to divide by negative 1 to get rid of that negative. So I have the square root of x minus 4 equals positive 13. To get rid of the square root symbol, I'm going to square both sides. Oops, that was a very good parenthesis. The square and the square root cancel. X minus 4 equals 169. Add 4 to both sides. X equals 173. And that's my answer. Alright, number 25, we do have an isolated square root, so we're going to go ahead and square it from the very first, both sides. Alright, notice that this puts x minus 10 is squared, but it's in parentheses. So squaring my square root cancels, But x minus 10 squared means x minus 10 times x minus 10. And I can use FOIL, or I can use the process we learned last chapter where you square a binomial. But either way, I'm going to get x squared minus 20x plus 100. That's what you would get if you did FOIL also. Alright, so what do you do if you have x squared in a problem? Well, you want to get one of the sides equal to 0 so that you can factor. So I'm going to start by subtracting 44 and adding 2x. And notice that I'm combining them with their like terms. So I have 0 equals x squared minus 18x, because when you combine negative 20x with 2x, that's what you get. And if you have 100 minus 44, then you get, what, 56? And that's going to be positive. Alright, so now I'm going to try factoring this. So I'm going to have x and x. What multiplies to give me 56 that could add up to give me negative 18? And all I can think of, let's see, 56 becomes 7 times 8. Or it could also be what, 4 times, oh there it is, 4 times 14. So if I did minus 4 and minus 14, I would get 56. If I have x minus 4 equal to 0, I get x is 4. And if I have x minus 14 equal to 0, I get x equals 14. And so there I have my solutions. Okay, you're going to finish the review on your own. Feel free to come check and see if your answers are correct and prepare yourself for the test.